All right, that's enough. So again, we are talking about spheres. A sphere is the set of all points equidistant from a given point called the center, but that has all points in space. So it's a three-dimensional. Think of your center, and it's all of the points that are the same distance from that. So a ball, the earth, okay, anything like that is a sphere. The great circle is a circle drawn on a sphere that has the same center and radius of a sphere. What could we relate to the great circle as planet Earth? The great circle on Earth. What? Say that again. The equator. Okay. The great circle. That's what cuts the Earth. That's in the center of the Earth. Yes, not in the center, but in the middle of the Earth around it. Okay, so it is a circle. It is drawn on a sphere, and it has the same center and the radius as the sphere. So what we mean by that is when we draw a circle,
the length around the sphere.
Okay, it has the same center and radius. So the great circle would be like right around there. If that makes sense. Okay, so like the equator on Earth. And then a hemisphere is one of two congruent halves of a sphere separated by the great circle. Speaking of Earth, we have the northern and southern hemisphere. Okay, so that's a very good example of a sphere and what the parts look like. Okay, ready?
No. No mail.
Just while we're waiting for them to finish writing, on your test, I will give you that, reference sheet that you'll get to use on the EOC so that it has some of the formulas on it. Okay, I'm not going to tell you exactly which ones. You saw some of them the other day. It does have also some of the volume formulas. So I will let you use that on the test next Wednesday.
What happens if we don't test the EOC?
You gotta retake the class?
No. It's going to count as part of your overall grade for this class. So it's not like the Algebra 1 where you have to pass to graduate. You just have to take it. Okay. However, it is a fifth of your grade. So if you're doing pretty well and then you bomb that, if you've been maintaining an A all year and you bomb that, you could get a B for the year. Okay.
That's not bad. I'm willing to
4 points versus 3 points in your GPA. It's kind of bad. Right?
No, lowest.
Well, first of all, I feel like you guys, especially after looking at those first couple of questions that I looked at this morning, if they're anything like that, you guys will be fine on the EOC. According to the first two questions that I looked at, I didn't go past there. I didn't go past there.
Hey, listen, all you gotta do is look at the last.
Last two?
Yeah, the first two are gonna be white. Yeah, that's
No, because listen, they give you a hard to you in the middle, but then they first you down.
yes, right in the middle. Right.
So I would just say look at the practice test online and you judge and see what you think. That kind of will give you an idea of how much you probably need to study.
You got that?
Are we ready now? Colin, are you good? Good? Okay. All right, so there's just a picture, not that you need to draw that, but talking about the hemispheres and the great circle. Here are your two formulas. Yeah, like if it doesn't divide evenly, just leave it as a fraction. That'll be easiest, because especially when your denominator is 3, it gives you a repeating decimal a lot, and I don't want to have to deal with that. All right, surface area. Melvin, what's the formula for surface area?
4 pi radius squared.
Okay, what's my radius? 2. So we're going to go 4 times pi times 2 squared. Order of operations says we have to square before we multiply, right?
Right.
2 squared is 4. And 4 times 4 is 16. So the surface area of that sphere is 16 pi. Then for volume, formula for that is 4 times pi times radius cubed and then divided by 3. So 4 times pi times 2 to the third power. What is 2 to the third power? 8. 8 times 4 is So 32 pi over 3, does 3 go into 32 evenly? No, so I'm going to leave my answer just like that because I don't want any repeating decimals.
Does not seem right.
Does everybody understand?
Yeah.
Okay. It's as long as you have the radius, you just plug your stuff in. We're finding how much surface area the ball has. So imagine if you had a Christmas present that's the ball and you're trying to wrap it, that's the surface area, what covers it. Volume is how much stuff you can fit in it. Okay?
And what's the point of the great circle?
Because it cuts it in half, basically. 32 pi over 3. All right, go ahead and try this one. Find the exact surface area and volume of a sphere with a diameter of 12. Find the exact surface area and volume of a sphere with a diameter of 12. Or, you know, they might give you a problem and say the great circle has a radius of this. You just have to know the great circle has the same radius that the sphere does. It just depends on what type of question you get as to how they can throw that at you.
6 times 6 times 6. Whoa. What? Done. Wait, isn't that like yeah.
So if there were
Wait, the other one is
surface area.
Is it double?
Yeah. Yes.
Miss Bridges.
I mean, hey, but could it be
You're such a joke, bro.
really good way?
Hey, we found a glitch.
What's the glitch?
Is it supposed to be double?
That's what Sebastian was just asking me. Is it always going to be that way?
I think it.
Wait.
Technically though, let's go back. Listen, to answer your question on the other one, it technically isn't double because the surface area is 16 pi. The volume is 32 pi divided by 3. But listen, 32 is 16 doubled, right? But we're dividing it by 3. Whereas you're telling me the answers that you got here straight out are doubled without the dividing by 3. So I would say no, it doesn't always work.
Not true all the time.
Make sense? With the 3, yeah.
No, you only refuted it to show how good I am.
All right, so surface area, again, is 4 times pi times radius squared. If my diameter is 12, what is my radius? So we're going to square 6. 6 squared is 34, and I'm sorry, 36. And 36 times 4 is 144 pi. Volume is going to be 4 times pi times my 6 cubed divided by 3. 6 cubed is 216. 216 times 4 is 864. Okay, but you still have to divide it by 3. And that gives me 288 pi. So since we already divided by 3, then no, that double idea is not going to always work. Anybody have any questions on those?
No.
Okay, it's plugging it into the formula. Yep. I'm sorry, I was looking to see what else I had. If I have the surface area and I'm looking for the volume, what is the only thing that is in either of those formulas for spheres? The radius. So the surface area, remember, is 4 times pi times radius squared, right? So they told me my surface area was 36 pi, so I'm plugging that in. I just need to solve this for radius. So I'm going to divide both sides by 4 pi, correct?
Yeah.
Okay, which is what a lot of y'all are doing in your heads, which is fine. Okay. The pi's cancel and 36 divided by 4 is 9. And then we have to take the square root of that to find the radius is 3. Okay. Then we plug it into the volume formula. 4 times pi times my radius cubed divided by 3. Bless you. Sebastian, no, you were wrong. I did not forget a pi.
It says 36.5.
Is that an R?
So 3 to the third. Shh.
I'm sorry.
3 to the third is 27. 27 times 4 is 108. So that gives me 108 pi divided by 3, which gives me,
36.5.
Bro.
She really believes in that.
no, what I was trying to do in my head, not thinking about what I had already done in the calculator and made sure I was doing it right. So,
No more.
all right, everybody.